In this video, we'll be learning how to find the domain as well as the equation of any vertical asymptote for simple rational functions looking like this. F of x equals to a over cx plus d. And to do this, we're going to use a couple of examples. The first is the following. F of x equals to 5 over 3x minus 6. Now, when given this type of function, the first thing we need to do is determine its domain. And to do this, we need to remember that for rational functions, we have a function on the denominator. And in this case, we can see that we have 3x minus 6 on the denominator. And the one thing we need to make sure of is that 3x minus 6 doesn't equal to 0, because we cannot divide by 0. So the way we go by doing this is by working out the value of x which would lead to 3x minus 6 being equal to 0. So we solve 3x minus 6 equals 0. This leads us to 3x equals to 6, which leads us to x equals to 6 over 3, which finally leads us to x equals to 2. Now, what we've just found here, this x equals to 2, is the one value that would lead to the denominator being equal to 0. In other words, that is the one value that x mustn't be equal to. We cannot plug x equals to 2 inside this function. So the domain is all real numbers except for 2. And we can go ahead and write this as follows. Domain equals to any x in R such that x not equal to 2. This is just another way of saying that the domain is any real number except for 2. Now, what this also leads to is a vertical asymptote on this function's curve. And the vertical asymptote has an equation. So I'll just write vertical asymptote. It's a vertical line that the curve never crosses. And its equation is quite simply x equals to 2. And in fact, you can go ahead with your calculator, and if you plot the curve y equals to 5 over 3x minus 6, you should see that at x equals to 2, the curve seems to split into two parts. And that line, x equals to 2, is the vertical asymptote. And the value x equals to 2 is the one value of x which isn't inside this function's domain. And you should find that the curve will look something like this. And there you have it. We've just seen how to find this function's domain and the equation of its vertical asymptote. Now, let's look at another example. Example 2. Let's say we're given the function f of x equals to negative 2 over 5x plus 15. Now again, our first step is to determine at which value of x, if there are any, at which the denominator equals to 0. So we solve 5x plus 15, which is the denominator, equals to 0. This leads us to 5x equals to negative 15, which leads us to x equals to negative 15 over 5, which finally leads us to x equals to negative 3. So this means that when x equals to negative 3, or rather if x equals to negative 3, then the denominator of this function would equal to 0, which isn't possible. We cannot divide by 0. Therefore, this function's domain will be any real number except for negative 3. And we write this domain equals to any x in the set of real numbers such that x is not equal to negative 3. And this in turn leads us to see a vertical asymptote along with this curve. And we can write its equation, vertical asymptote which remember is a vertical line that the curve never crosses, its equation is x equal to -3. And so if you plot the curve y equals to -2 over 5x plus 15 on an xy grid, you should see that at the value x equals to -3, the curve seems to split into two. And so we can draw a vertical asymptote, a vertical line, at x equals to -3. And its equation is x equals -3. And if you've plotted this with your calculator, you should see that the curve will look something like this. And there you go. That's how we find the domain and the equation of the vertical asymptote for this type of rational function.